While simple bar charts show a great deal of information, they sometimes leave out factors we might want to know, such as consistency. A team whose average score varies more from its maximum is also often more prone to defense, making it a good target for a defensive team. In this video, we will create different views to answer questions about which teams to ally with and when to play defense on certain teams. We will also cover some filtering options to further increase our clarity. A normal bar chart only shows its aggregation. If we want to see how dependable a team is, the usual method is to change the aggregation to standard deviation, a statistical measure of variability. Now we can see the standard deviation, but we forget how many points they score. A slightly better way is to drag standard deviation onto color. However, this has its own problems. If we see a team that has a standard deviation of 5 or 30 points, what does that really mean? We have to do a lot of math in our head, and that step of thinking interrupts the whole point of visualizing data, to quickly gain insight. The stacked bar charts we are going to create show the minimum, average, and maximum of the field we want to see. This helps us get a better idea of the distribution of that team's performance than standard deviation due to context and association. From the size of the gaps between the marks, we can infer the variability of team's performance. A team with much larger differences between these aggregations is probably more variable than a reliable team with less space. I will go over how to read into these graphs a little more after we've made one. Let's create a new sheet. To rename it, double-click it. Let's name this one Total Score. To make our first staff bar graph, we start by dragging out team number onto the rows shelf. Then, drag Total Score onto the columns shelf and change it to an average. Drag Total Score onto the graph again, but this time hold it over the x-axis until these twin bars come up. Make sure there is twin bars instead of just one. By doing this, we are now graphing both of them at the same time. Change it from sum to a minimum. Let's drag Total Score on once again, but this time right-click drag. By right-click dragging, this dialog box comes up and we can aggregate my max right off the bat. This triple graph here is not a bad graph. It shows all of our data very clearly. However, it takes up a lot of space. To turn this into a stacked bar graph, drag measure names from the column shelf and onto colors. To help us remember that these bars are all measuring the same field, I like to change the color palette to a gradient. Coloring is a very important concept. If we keep all of the graphs of a certain game period the same color, we immediately know what period of the game this graph represents. If we look down at the x-axis, something seems off. Teams should not be scoring that many points. The reason why this is happening is because we haven't turned off stacking yet. Go to Analysis, Stack Marks, and turn them off. Now our fields are where they should be. In order to sort these graphs, we have to do it the more advanced way. To sort our teams by any field, right-click on the team number and select Sort. Change the sort method to by field. In this case, we want to sort by total score. Sorting by average is probably the best aggregation we can sort by because it is near to what a team can be expected to perform on any given match. Now, these teams go down very smoothly by average of total score. Now that we know the process to create these visualizations, let's relook at the sheets I've already made for autonomous, tele, and end score. Notice in a team like this, where the whole bar is the color of the minimum score. In this case, it means that team 5116 always scores that many points. This makes them very reliable. Notice that because all of our graphs are gradients, we immediately know which period of the game it represents. I prefer using stacked bar charts like this one because they show us a few things from the distribution of these aggregations. A robot that doesn't have a minimum score of 0 is a robot that always manages to score some points, so we can assume that they never break down. A team that has a huge difference between its maximum and its minimum probably is very influenced by their opponent. This might be a team to prioritize playing defense on. Following that train of thought, a robot that doesn't have very much variation is probably a very consistent partner and can play very well in the face of defense. There is one more stacked bar chart that is very useful, and I call it the distribution chart. The distribution chart divides up a team's average total points into 3 periods so that we know when to play defense against them. Drag team number onto rows just like we did before, and then drag on autonomous score, tally score, and in score. Make sure you drag it on so that there are dual bars. Then change each of these fields to averages. Drag measure names onto color again, and we have our stacked bar chart. Notice that our stacked bar chart automatically colors itself based off of the same gradients that we have picked before. Also in this stacked bar chart, we don't have to turn off stacking because we are adding up the total of these 3 periods. If this chart is used right, it is one of the most useful bar charts for defense because it lets us see everything at the same time. For instance, a robot that makes most of its points during teleop would be better to defend against than one that makes most of its points during autonomous. Furthermore, a robot that has a very good endgame should be kept away from that goal at all costs. Just how stacking helps these charts become more clear than a normal bar chart, we can filter our data to further clarify our data. Currently, our end score graph is aggregating our data based off of every match, whether or not they even attempted to climb. If we wanted to see how good they were at climbing if they decided to, we can filter out all the matches where the team didn't attempt to climb. To make a filter, drag on a dimension or measure onto the filter shelf. In this case, we only want the matches where attempt equals true. Immediately, there are a lot more teams that always could climb if they tried to. However, filtering it in this way allows for teams that only attempted to try a few times and were successful to sneak in among the teams that tried lots of times and were successful. To see how many times a robot actually tried to climb, I like to drag number of records onto the size shelf. Now, all the teams that only tried once and got lucky are visible. Filtering is even more useful when filtering match number. Not all teams do very well on their first few matches, so by filtering match number, we can ignore the rough starts. Let's drag match number onto the filters shelf. As you can see, we can manually pick and choose which match numbers to keep, but there is an easier way. Go to match number and change it to continuous. That will make Tableau stop treating each match like its own independent event and start treating match like a scale. Now we can ignore the first 20 matches. If we are planning to change a filter often in the future, we can create a quick filter. To turn any filter into a quick filter, right-click on it and show quick filter. Now, by dragging this slider, we can rapidly change the match range. If we want this new filter to apply to every sheet on the workbook, we can make any filter a global filter. To make a filter apply to all the sheets in a workbook, right-click on the filter and then make it apply to all using this data source. Now, if we go over to a different sheet, the data will change accordingly. We have gone over a few ways that we can clarify our data. By adding stacked lines, we get a better idea of the distribution of a team's performance. With filters, we can focus our view on what is really relevant. Building our charts to be as clear as possible is something we should strive for. Thank you.